At the beginning, for the rate of reaction and equilibrium, what is the difference or factors affecting rate and factors affecting equilibrium? And what is the difference between rate and equilibrium? Rate, it means a change per time. A change mass per time, change volume per time, a change concentration per time, and rate affects speed, not amount. Rate makes the reaction faster, but the amount, final amount, must be the same. You must concentrate with me. For example, if I have faster and slower rate of reaction, if I have two reactions, we can say for number A and B that A faster rate of reaction than B, okay? The same final amount for both must be the same. If I make like that, A and B, faster rate to be like that, wrong. Rate affects speed, not amount. Speed to be faster or slower, but the final amount must be the same. This is number one. Okay. What are factors affecting rate of reactions? Factors affecting the rate we have temperature, pressure, concentration, catalyst, and surface area or nature of substance, like surface area. So these are the factors affecting rate of reaction. For the factors affecting rate of reaction, temperature, pressure, concentration, catalyst, and nature of reacting or surface area. For temperature, by increasing temperature, particles gain kinetic energy. And then particles moves faster. After that, more collisions between particles. Rate of reaction will be faster. Again, for the rate of reaction, we said that rate means change per time. Change mass per time, volume per time, concentration per time. And rate affects speed, not amount. It means that faster rate or slower rate, this means that the speed of the reaction, not the amount. The final amount must be the same. Faster rate for A and B, we said that A is faster rate than B, but the total final amount for both are the same. Okay, this is number one. Number two, factors affecting rate, temperature, pressure, concentration, catalyst, and the nature of reactants. This means that these are factors affecting the speed of the reaction, not the amount. For number one, we said that temperature. By increasing temperature in the kinetic theory, you will find that particles gain energy. And we can say particle gain energy only in case of temperature. Particles gain energy. And then particles move faster. And then more collisions, faster rate of reaction. In pressure and concentration, we can say that particles gets closer, and then more collisions and rate will be faster. Why particles gets closer? By increasing pressure, by decreasing the volume, because pressure and volume inversely proportional. So by increasing pressure, it means that you're decreasing the volume. This means that particles gets closer. And for concentration, what's meant by concentrated little amount of water? What's meant by diluted more water? This means that in concentrated solutions, particles are close to each other, more collisions and faster rate of reaction. In a catalyst increase the rate of reaction. Why? Because in catalyst, lowering activation energy. What is meant by activation energy? The minimum amount of energy to start the reaction. So in case of using a catalyst, the amount of energy required to start the reaction will be decreased. And also for nature of the substance or the surface area, by increasing surface area, the rate of reaction will be faster. By increasing surface area, it means that decreasing particle size. For example, if you have magnesium strap and magnesium powder have faster rate of reaction. Why? Because it has larger surface area or decreasing particle size. So the factors affecting rate, temperature, pressure, concentration, catalysts, and nature of reactants or surface area, all of them directly proportional. By increasing any factor, the rate of reaction will be increased. And also you'll find that in temperature, it depends on kinetic energy. By increasing temperature, particle gain energy, particle moves faster, more collision, and the rate of reaction will be faster. In case of pressure and concentration, the particles gets closer and then more collision and the rate of reaction will be faster. Catalyst. By adding catalyst, a catalyst is a chemical substance increase the rate of reaction without being changed or without being used up. And by adding catalyst, lowering activation energy. What's meant by activation energy? The minimum amount of energy to start the reaction. And also surface area. By increasing surface area or decreasing particle size, the rate of reaction will be faster. And we said for the rate to be faster, the height of both must be the same. So they have final amount, but the difference is change per time faster, mass per time, volume per time, or concentration per time. And you will find also for the volume with time, it will be directly. So if we have volume with time, directly. But in case of mass with time or concentration with time, decreasing gradually. While loss of mass or volume will be directly. So loss of mass or volume directly with temperature, with time, while mass or concentration will be inversely with time. After that, factors affecting equilibrium. What is the difference between rate and equilibrium? Equilibrium, it means that two directions, reversible reaction. So what's meant by equilibrium? When the rate of forward reaction equal rate of backward or reverse reaction, and the concentration of reactants and products is still constant or doesn't change. Again, equilibrium proceeds in two directions to be reversible reaction. And in case of equilibrium, when the rate of forward reaction equal rate of backward reaction and the concentration of reactant and product is still constant. And then in equilibrium affects amount and speed. While in case of rate, we said that rate affects speed, not amount. While in case of equilibrium affects amount, not speed. What are the factors affecting equilibrium? Factors affecting equilibrium, we have concentration, pressure, and temperature. In case of concentration, by increasing the concentration is for liquid, pressure for a gas, by increasing concentration, the reaction moves from high concentration to low concentration. For example, if you have a reaction and then we need to know the effect of equilibrium. Like, for example, if we have C2H5OH plus CH3COOH CH3COOC2H5 plus H2O. By increasing concentration of reactants or decreasing products, the reaction moves forward and more yield is produced. Again. Factors affecting equilibrium. We said that concentration, pressure, and temperature. For the first one, in case of concentration, by increasing the concentration, the reaction moves from high concentration to low concentration, okay? In case of increasing concentration of reactants or decreasing concentration of the product, this means that the reaction moves forward. Reaction moves forward, it means that more yield is produced. Moves backward, it means that less yield is produced. So when the reaction moves forward, it means that more yield is produced. While in case of backward or reverse, less yield is produced. So again, for the first one, concentration, by increasing the concentration of reactants or decrease concentration of the products, the reaction moves forward and the more yield is produced. So this is for concentration. So we can summarize for concentration. Concentration, it moves from high concentration to low concentration. And in case of increasing concentration of reactants or decreasing concentration of products, reaction moves forward and more yields produced. Okay, this is number one. Number two, in pressure, pressure moves from more number of moles to the less number of moles. For example, if we have N2 plus 3H2 gives 2NH3, 2SO3 gives 2SO2 plus O2, H2 plus I2 gives 2HI. In case of increasing pressure, what will happen? In each case, the number of moles in reactants equal 4. And you must know that pressure for gas only, concentration for liquid. So 4 moles, and as a product we have 2 moles. By increasing pressure, the reaction moves to the less number of moles, so it moves forward and more yield is produced. In case of number 2, we have 2 moles and we have 3 moles, and the reaction moves from high number of moles to the less number of moles. So in the second one, it will be moved from 3 to 2. So the reaction moves backward and less yield is produced. Number 3, the number of moles in reactants 2 and the number of moles in product 2, so pressure doesn't affect equilibrium state. Again, concentration from high to low. By increasing the concentration of reactants or decreasing concentration of product, the reaction moves forward and more yield is produced. Okay. Number 2, pressure. By increasing pressure, the reaction moves to the less number of moles. In case of in pressure, from high or more moles to less moles. In case of number of moles of reactants is greater than products, so by increasing pressure, reaction moves forward and more yields produced. In case of number of moles of product greater than reactants, by increasing pressure, the reaction moves backward and less yield is produced. In case of number of moles of reactants equal to the number of moles of products, this means that equilibrium, so pressure doesn't affect. Why? Equilibrium. Why is equilibrium? Number of moles of reactants equal number of moles of products. This for pressure. Okay. So here 4 and 2 moves from 4 to 2, moves forward, the more yield is produced. And number 2, 2 and 3, so it moves from 3 to 2, moves backward and less yield is produced. This is in case of increasing pressure. If we decrease the other side, 2 moles and 2 moles, by increasing pressure, the reaction doesn't affect equilibrium state. For the third one, temperature. In temperature, it depends on the type of reaction. The reaction in case of endothermic reaction and exothermic reaction. In case of endothermic reaction, it means that delta H is positive. And in case of exothermic reaction, delta H is negative. Okay, for temperature, in case of temperature, endothermic reactions and exothermic reactions. In endothermic reactions, it means that heat is taken and delta H is positive. By increasing temperature for endothermic reaction, reaction moves forward and more yield is produced. While in case of exothermic reaction, by increasing temperature, reaction moves backward and less yield is produced. So for that reasons, we must know that if we have any reactions in case of concentration, we need to increase reactants or decrease products to make the reaction moves forward to obtain more yield. How to obtain more yield? In concentration, increasing reactant or decreasing product. In pressure, if the reactants is greater than the products, so we must increase the pressure to make the reaction moves forward. In case of number of moles in product is greater than reactants, we must decrease the pressure to make the reaction moves forward. If the number of moles are equal, no effect. After that, in case of temperature, if we have endothermic reactions, we must increase to make the reaction moves forward. Exothermic reactions, we must decrease to make it moves forward. If you find in 2 examples for that, N2 plus 3H2 gives 2NH3, and 2SO2 plus O2 gives 2SO3. You will find that both reactions are exothermic. This means that delta H equal negative for both, and both are reactions reversible. And then asking you about why you are using low temperature, explain why for both. Why you are using high pressure for both. Why you are adding catalysts for both. The first one, why you are using low temperature? Because the reaction is exothermic. So by decreasing temperature, the reaction moves forward and more yield is produced. The reaction is exothermic. So by decreasing temperature, the reaction moves forward and more yield is produced. Number 2, why increasing pressure in this or that? The number of moles and reactants is greater than number of moles in products, because the number of moles and reactants is greater than products. So by increasing pressure, the reaction moves forward and more yields produced. Number 3, why you are adding catalysts? You will find that we are decreasing temperature. This means that we have one advantage and one disadvantage. Advantage, more yield. Disadvantage, a slow rate of reaction because you are decreasing temperature. So what is the improvement to add a catalyst to speed up the reaction? So in which cases we must use catalysts? In case of, if we have number of moles and pressure and product is greater than reactants, so we must decrease the pressure. So in this case, the improvement to add catalyst. Why to add catalyst? To make faster rate. Why you are decreasing here? To obtain more yield. Also, in case of exothermic reaction, we must decrease to obtain more yield. Also, the improvement to add a catalyst to obtain faster rates. So, in case of pressure, as the number of moles and product is greater than reactants, you are adding catalyst to obtain to a faster rate, and also in case of exothermic reactions for faster rate. So there's the difference between rate and equilibrium. This is the first point today. Rate, it change per time. It change mass per time, volume per time, concentration per time. Rate affects speed, not amount. Faster rate or slower rate, both have the same final amount, but the difference for the rate of reaction to be faster or slower. Volume with time or loss of mass with time will be directly proportional. Mass or concentration with time will be inversely proportional. After that, factors affecting rate, temperature, pressure, concentration, catalyst, and nature of reactants or surface area. Temperature, particles gain energy, particles move faster, more collisions, and faster rate of reaction. While in case of pressure and concentration, you will find that particles gets closer and then more collision and faster rate of reaction. In a catalyst, lowering activation energy. What's meant by activation energy is the minimum amount of energy to start the reaction. So by adding catalyst, it means that you are lowering the amount of energy required to start the reaction. Nature of substance, it means that surface area, by increasing surface area or decreasing particle size, it means that the reaction will be faster. So all of these factors directly proportional for the rate, temperature, pressure, concentration, catalyst, and surface area. All of these factors are directly proportional. By increasing any factor, the rate of reaction will be faster. After that, equilibrium. What is meant by equilibrium? Rate of forward reaction equal rate of backward reaction, and the concentration of reactant product is still constant, doesn't it change? And equilibrium affects amount, not the speed. In case of moving forward, it means that more yield is produced. In case of backward or reverse reactions, it means that less yield is produced. Factors affecting equilibrium, concentration, pressure, and temperature. For concentration, the reaction moves from high concentration to low concentration. And pressure, from high number of moles or more number of moles to the less number of moles. In case of temperature, it depends on the type of reaction. In case of endothermic reaction or exothermic reaction. The first one for concentration. By increasing the concentration of reactants, or decreasing concentration of products, reaction moves forward and the more yield is produced. After that, concentration moves from high concentration to low concentration. So in case of increasing concentration of reactants or decreasing concentration of the products, the reaction moves forward and more yield is produced. After that, in case of pressure, by increasing pressure, the reaction moves to the less number of moles. So the reactants have 4 moles, product 2 moles. By increasing pressure, reaction moves forward from 4 to 2 and the more yield is produced. If we increase pressure in case of number of moles in product is greater than reactants, so it moves from product to the reactants. So it moves backward and then less yield is produced. H2 plus I2, the number of moles are equal in both sides, 2 moles and 2 moles. So pressure doesn't affect equilibrium state, equal number of moles in both sides. The last one, pressure. We said in pressure from high moles to the less moles in case of number of moles of reactants is greater than products. This means that the reaction moves forward and more yield is produced. If we have number of moles in product is greater than reactants, so by increasing pressure, reaction moves backward and less yield is produced. In case of number of moles of reactants equal number of moles in products, this means that pressure doesn't affect equilibrium state. The last one, temperature, endothermic and exothermic reactions. Endothermic, it means that heat is taken. Exothermic, it means that heat is given out. An endothermic reaction, by increasing temperature, the reaction moves forward and the more yield is produced. While in case of exothermic reaction, by increasing temperature, reaction moves backward and less yield is produced. So how to obtain more yield in concentration, increase reactant or decrease product? In pressure, if you have reactants greater than product, increase. If you have product greater than reactant, decrease. This to obtain more yield. In case of equal number of moles, pressure doesn't affect. An endothermic reaction, increase the temperature, makes the reaction moves forward. In exothermic reaction, we must decrease temperature to make the reaction moves forward. Practically, in Haber process and the contact process for preparation of ammonia and sulfur trioxide, both reactions are exothermic and reversible. So we must use low temperature. Explain why? Because the temperature reaction is exothermic. So by decreasing temperature, the reaction moves forward and the more yield is produced. In case of pressure, by increasing pressure, the reaction moves to the less number of moles, so it moves forward and the more yield is produced. Adding catalyst, why we are adding catalyst? To speed up the reaction, because in case of temperature, we are using low temperature. In using low temperature, we have advantage and disadvantage. The advantage, more yields, the disadvantage is slow rate. What is the improvement for that? To add a catalyst to speed up the reaction. Okay. This for the first one, the difference between rate and equilibrium. After that, an acid and base, for the rate, this is the rate, faster rate and the slower rate. And we said that for volume with time or mass with time, you will find mass with time inversely while volume with time directly. After that, in case of acid and base, making salts, in making salts, you must know that making salts, In making salts, we have to know making soluble salts and making insoluble salts. Making salts, we have making soluble salts and making insoluble salts. For making soluble salts, we have two methods: neutralization or excess, and the other one is titration. How to prepare insoluble salt? By precipitation. Again, making salts, we have making soluble salt and making insoluble salts. Making soluble salt by two methods: neutralization and titration. The insoluble salt by precipitation. What is the difference between each one? In neutralization, the reaction formed between base and acid, while in case of titration, it is formed between both alkali, which is aqueous, and acids. In precipitation, two soluble salts reacting together to form soluble salt and insoluble salt. Again, for making salts, we have two methods: making soluble salts and making insoluble salts. Making soluble salt by two methods: neutralization or excess, this is number A, and titration, this is number B. For the first one, neutralization or excess method formed between base and acid, while titration, alkali and acid. So what is the difference between base and alkali? Base, this is a solid and must be metal or metal oxide or metal hydroxide or metal carbonate. Again, for example, the reaction between zinc and hydrochloric acid, zinc oxide, zinc hydroxide, zinc carbonate reacting with HCl. So all of them, metal, metal oxide, metal hydroxide, metal carbonate, all of these are considered as a base: metal, metal oxide, metal hydroxide, metal carbonate, and must be solid. You will find it mainly transition metals. And then reacting with an acid. In case of reacting with metal, it will produce salt and hydrogen. Metal oxide or hydroxide, it will produce salt and water. In case of metal carbonate, it will produce salt, water, and carbon dioxide. Again. The reaction in neutralization or excess method formed between base, which is metal, metal oxide, metal hydroxide, metal carbonate, and must be solid, reacting with an acid, like zinc, zinc oxide, zinc hydroxide, zinc carbonate, reacting with any acid like HCl, H2SO4, HNO3. You'll find that acid plus active metal, metal oxide or hydroxide, metal carbonate or bicarbonate, all of them will produce salt But in case of metal, salt and hydrogen, metal oxide or hydroxide, salt and water, metal carbonate and bicarbonate, salt, water, and carbon dioxide. This is the first method. How can we make? For the first method, for example, if we have zinc oxide or copper oxide reacting with sulfuric acid, at the beginning, we must heat the acid. Why we are heating the acid? To speed up the reaction. And then by using a spatula, we are transferring the copper oxide. Then stirring with glass rod. Why we didn't stir with a spatula? Not to react. Add until excess. What's meant by excess? More than enough. Why we are adding in excess? To make sure that all acids reacted. How can we know this excess? Solid appears down, and we can't say precipitate. Solid appears down. Then number two, this is number one. Number two, we'll make filtration. Why will make filtration? To remove excess metal oxide. Number three, crystallization. Heat, cool, filter, dry. So crystallization, heat, cool, filter, and then dry. Here's the solution till crystallization point. How can we know that crystallization point has been reached? Mixing with glass rod crystals formed. Allow to cool, and then filter, and then dry. Drying between two filter papers. Why we didn't dry on a Bunsen burner or oven? Because to lose water of crystallization, prevent losing water of crystallization, or broken down of the crystals or melting of the crystals. So again, this is the first method. I repeat again. All of you must concentrate. Number one, we are heating the acid. Why we are heating the acid? To speed up the reaction. And then we are adding the metal oxide. Metal oxide, metal hydroxide, metal carbonate. But in case of metal, we must have active metal. Active metal, for example, if you are using copper with HCl, no reaction. But copper oxide, hydroxide, copper carbonate can react. So in case of metal only, we must have active metal, like zinc, like magnesium. Okay, after that, copper oxide we are adding by using spatula. Then stirring with glass rod. Why we are stirring with glass rod? Not to react, and then adding until excess. What is meant by excess? More than enough to react. How can we this excess? Solid appears down. Why we are adding in excess? To make sure that all acid reacted. Then number two, filtration to remove excess metal oxide. Number three, we'll take the filtrate to make crystallization. Heat the solution till crystallization point, allow to cool, then filter, and then dry. How can we know that crystallization point had been reached? Mixing with glass rod crystals formed. Why we didn't dry on a Bunsen burner or oven? To prevent losing water of crystallization, or to prevent melting of the crystals or breaking down of the crystals. The last question is this point: what is the difference if we use metal or metal carbonate instead of metal oxide and metal hydroxide? In case of metal or metal carbonate, metal will produce hydrogen gas, metal carbonate carbon dioxide gas. So it is exothermic reaction will produce a gas. So what is the difference if we use metal or metal carbonate instead of metal oxide or hydroxide? Two reasons. The first one, no need to warm the mixture. The reaction is exothermic. And number two, the reaction stopped when gas stopped. Here we are adding in excess to make sure that all acid reacted, but in case of a gas, the reaction stopped when gas stopped. This is number one. This is number one. Number two, titration. In titration, we said that this formed between both alkali and acid. So both of them are aqueous, like the reaction between in titration, like the reaction between sodium hydroxide aqueous plus hydrochloric acid aqueous to form sodium chloride and water. Both of them are aqueous, so we must have titration. In titration, we are filling the burette with acid, take known volume of alkali, and then add 2 or 3 drops of indicator. For the indicators, we have the type of indicators. We have litmus and methyl orange, phenolphthalein, thermophthalein. So it depends on the type of indicators that you are using. For example, here, if you are making the reaction and using methyl orange, so filling the burette with acid, take known volume of alkali, and indicator like, for example, methyl orange, and start titration until the color change from yellow to orange. For example, if you are using phenolphthalein until the color change from pink to colorless, and then repeat without indicator and then make crystallization. Again, in titration, formula between alkali and acid, both are aqueous. Filling the burette with acid, take known volume of alkali, and then add drops of indicator, start dropping until the color change. If we are using methyl orange, until the color change from yellow to orange. Or if we are using phenolphthalein, until the color change from pink to colorless. After that, repeat the experiment without indicator and make crystallization. Why we are using indicator at the beginning? To indicate the ending point. Why we are repeating without indicator? To obtain pure crystals. And then crystallization, heat, cool, filter, dry. The last one, preparing insoluble salts. In preparing insoluble salts, precipitation methods, we must add two soluble salts mixing together. For example, if we have sodium nitrate or sodium chloride reacting with silver nitrate, both of them are aqueous, reacting together to produce sodium nitrate and silver chloride solid. So at the beginning, we have a mixture of the two salts, adding water and stirring. So at the beginning, add water to the mixture, stir, then filter. After filtration, we have residue and filtrate. What is the difference between filtrate and residue? Residue, which is water insoluble. Filtrate, which is water soluble. If we need to obtain crystals of the residue, we must make wash with distilled water, then dry. For filtrate, we must make crystallization. Heat, cool, filter, dry. After that, we must know the insoluble salts. Insoluble salts for chloride, silver, and lead. Silver chloride and lead chloride. All chlorides are soluble except silver and lead. In case of sulfate, all sulfates are soluble except barium, calcium, and lead. In case of carbonate and hydroxide, all are insoluble. All are insoluble except sodium, potassium, and ammonium. So again, the insoluble salts for chloride, silver, and lead, sulfate, barium, calcium, and lead, carbonate and hydroxide, all except sodium, potassium, and ammonia. So this is for making salts. So for making salts, we have making soluble salts by neutralization or excess. This formed between base, which is a solid metal, metal oxide, metal hydroxide, metal carbonate with an acid, and titration, reacting between alkali and acid, but both are aqueous. Precipitation, two insoluble salts mixing together to form soluble salt and insoluble salt. If we need to obtain soluble salt by crystallization, the insoluble salt washes and dry. After that, type of oxides. Acidic, basic, amphoteric, and neutral. What is the difference between them? Acidic oxides, non-metal oxides, and react with a base, like carbon dioxide, nitrogen dioxide, sulfur dioxide. Basic oxide, metal oxide. Which reacting with acidic oxide. Metal oxide, like sodium oxide, magnesium oxide, like that. Amphoteric, reacting with both acid and base. React with base and an acid, react with base and acid as a base. Like aluminum oxide and zinc oxide, reacting with both acid and base. Neutral doesn't react with anyone, like water, carbon monoxide, and nitric oxide. So again, the type of oxides, acidic, non-metal oxide, which react with a base, basic oxide, which is metal oxide, react with acidic, amphoteric, reacting with both, like aluminum oxide and zinc oxide. Neutral doesn't react with anyone, like water, carbon monoxide, and nitric oxide. After that, chemical tests. Chemical tests, we have number one, test of gases. Hydrogen, oxygen, carbon dioxide, chlorine, and ammonia. For hydrogen, with lightest blends. Oxygen, glowing blends. This is a test. Carbon dioxide, lime water. Chlorine and ammonia, litmus paper. In case of hydrogen, light blend burns the pulp, is cookie pulp. Oxygen glowing sponge or lights or glows more. Carbon dioxide, lime water, turbid or milky. Chlorine, litmus paper bleaches or turns white. Ammonia, turn red litmus paper into blue. This is the first one. Test of gases, hydrogen, oxygen, hydrogen, oxygen, carbon dioxide, chlorine, and ammonia. Light is blunt, burns the pop. Glowing is blunt, relights or glows more. Lime water, turbid or milky. Chlorine, litmus paper bleaches or turns white. Ammonia, turn red litmus paper into blue. And has pungent smell. For ammonia, you'll find it has pungent smell for ammonia. After that, test of anions. Carbonate, chloride, bromide, iodide, sulfate, and nitrate. Test and observation, and I said observation, not conclusion. The test, in case of carbonate, dilute hydrochloric acid, chloride, bromide, iodide, acidify means reacting with acid, then add aqueous silver nitrate or aqueous lead nitrate. Sulfate, acidify, then add aqueous barium chloride or aqueous barium nitrate. For nitrates, add aqueous sodium hydroxide, then aluminium powder or aluminium foil, then warm. This is a test. In case of carbonate effervescence of colorless gas makes lime water turbid or milky. Number 2, chloride, bromide, iodide. In case of chloride, will produce chloride white precipitate, bromide white, yellow, or creamy precipitate, iodide yellow precipitate. In case of sulfate, white precipitate. Nitrate, it will produce pungent smell. It change red litmus blue. So again, carbonate, chloride, bromide, iodide, sulfate, and then nitrate. In case of carbonate, dilute hydrochloric acid, effervescence of colorless gas makes lime water turbid. And what is the gas will be produced from carbonate? Carbon dioxide. And it is wrong if you say carbon dioxide gas evolves. No, observation, not conclusion. Colorless gas makes lime water turbid. Chloride, bromide, iodide, the halogens, acidifies and add aqueous silver nitrate or lead nitrate. In case of chloride, white precipitate, bromide, white, yellow, or creamy, iodide, yellow precipitate. After that, sulfate, acidify, then add aqueous barium chloride or aqueous barium nitrate, white precipitate. nitrate add aqueous sodium hydroxide, then aluminium foil, then warm. You will find that pungent smell change red litmus paper to blue. After that, for cations, the positive ions, we have copper, chromium, iron 2, iron 3, zinc, aluminium, calcium, and the last one is ammonium. With aqueous sodium hydroxide, you will find that in case of copper will produce blue precipitate insoluble in excess. Chromium, green precipitate that is soluble in excess. Iron 2 and iron 3. Iron 2, white green or dirty green, and iron 3, reddish brown. Both of them are insoluble in excess. Zinc, aluminium, calcium, all of them are white. Zinc, aluminium, calcium, white precipitate. But the difference in case of zinc, soluble, soluble. Aluminium, soluble, insoluble. Calcium, insoluble, no precipitate. There's a difference between aqueous sodium hydroxide and between aqueous ammonia, because all of them are white. So again, test for cations, we have copper gives the blue precipitate with aqueous sodium hydroxide, which is insoluble in excess. Chromium, green precipitate, which is soluble in excess. Iron 2, white green or dirty green, insoluble in excess. Reddish brown, which is insoluble in excess. In case of zinc, aluminium, calcium, white precipitate. And how to compare between them? In case of zinc, aluminium, calcium, we'll mix the reaction with sodium hydroxide, aqueous sodium hydroxide, and aqueous ammonia. In case of zinc, soluble, soluble in excess. Aluminium, soluble, insoluble. Calcium, insoluble, and no precipitate. Also, in chemical tests, we have, in chemical tests, test of water. Chemical test of water. We have physical and chemical test of water. Physical test of water. Melting in the boiling point 0 and 100. While in case of chemical test of water, anhydrous copper sulfate and anhydrous copper chloride. Copper sulfate and anhydrous copper chloride. In case of anhydrous copper sulfate, the color change from white to blue, while from copper chloride from blue to pink. Okay?
لما according للبريشر والتمبريتشر ده بيقول لي الايفكت بتاع البريشر هنا في الكيرف ده، فاللي انا شايفه according للكيرف ان انا البريشر لما بينكريز اليلد هنا كونستانت ما بيتغيرش. اما هنا اللي انا شايفه ان انا لما التمبريتشر بتاعتي بتنكريز اليلد بتاع البرودكت بيقل. طيب دكتور شريف لسه قايل دلوقتي ان انا البريشر بتاعي بيتاثر بالنمبر اوف مولز. فلو انا عندي مثلا A بلس B بيديني C بلس D، فانا محتاج الاول اللي انا اعرف النمبر اوف مول هنا كام والنمبر اوف مول هنا كام من حيث الرياكتنت والبرودكت، وبالتالي البريشر هيتاثر الايفكت بتاعه هيديبند على النمبر اوف مول. فبالتالي والله لو انا النمبر اوف مول بتاعي هنا مثلا هو هنا اكتر، فلو انا عملت انكريز للبريشر فانا هبعد عن البريشر الكتير ده اروح للبريشر القليل والعكس. فهنا لقيت ان انا البريشر بتاعي الايفكت بتاعه ما بيأثرش على اليلد، فمعنى كده ان انا النمبر اوف مول بتاع الرياكتنت بتاعتي هيكوال النمبر اوف مول بتاعت البرودكت بتاعتي. فدي اول نقطه. فبالتالي لما اجي اختار من هنا اكون مختار حاجه يكون النمبر اوف مول بتاعها زي بعضها. فانا هختار النمبر اوف مول لحاجه يكون النمبر اوف مول ده يكون رياكتنت قد البرودكت. لما نيجي نختار بقى نشوف. طيب انما الجزئيه الثانيه هنا لا، انا هنا لما بزود التمبريتشر لا بلاقي اليلد بتاع البرودكت بيقل. معنى كده ان انا لما اليلد بتاع البرودكت بيقل معنى كده ان انا بشفت للرياكتنت، مش بشفت او بشفت ناحيه الليفت، ببعد يعني بعيد عن البرودكت. ده معناه ايه؟ معنى كده ان انا لما بزود البرودكت يبقى اكيد ان الرياكشن بتاعي كان اكزوثيرميك، فكانت الهيت هنا من ضمن البرودكت، فبالتالي لما بزود التمبريتشر الايه الرياكشن بيشفت باكورد. تمام، يبقى انا كده عرفت نقطتين من التو كيرف بتوع ده. اول حاجه ان انا الرياكشن بتاعي هيبقى اكزوثيرميك رياكشن، تاني حاجه ان انا النمبر اوف مول بتاعت الرياكتنت هتيكوال النمبر اوف مول بتاعت البرودكت، وبالتالي اختار على الاساس ده. فبالتالي اول جزئيه هنا لما اجي احسب النمبر اوف مول مثلا كبدايه على اساس ان هو اسهل، فهنا 4 مول لكن هنا 2 مول، فدي تبقى غلط. هنا 2 مول وهنا 2 مول و1 مول، يبقى التوتال هنا في البرودكت 3 مول، فدي برضو غلط. هنا 1 مول اما هنا التوتال 2 مول، فدي برضو غلط. هنا 2 مول وهنا 2 مول، فالنمبر اوف مول هنا بيكوال بتاع الرياكتنت بيكوال النمبر اوف مول بتاع البرودكت، فدي احتماليه ان هي تبقى صح موجوده. طيب اي 2 مول وهنا هيبقى 3 مول، فاي برضو غلط. فلكن ان انا كده بالنمبر اوف مول بس قدرت اطلع الاجابه الصح. ولكن نكمل، انا قلت ان انا الرياكشن بتاعي لازم يكون اكزوثيرميك، واكزوثيرميك يعني انا عارف ان الدلتا اتش بتاعتي نيجاتيف، فمعنى نيجاتيف يعني less than زيرو، فالانسر بتاعتي دي هي الصح. حد عنده مشكله يا شباب في السؤال ده؟ تمام. حاول نشوف سؤال تاني. نيجي مثلا للسؤال ده اللي هو 4، ناكد برضو على نقطه الايكويجن والشيفتنج والكلام ده كله. فلما اجي هنا في السؤال ده بيقول لي والله ان انا عندي كربون دايوكسيد اند هيدروجين جازز بيعملوا رياكشن مع بعض في البريشر ده والتمبريتشر دي عشان اكون الميثايل الكحول، وده الايكويشن بتاعتي. وبيقول لي الباكورد رياكشن بتاعي از اندوثيرميك، يعني انا الهيت بتاعتي هتبقى جنب الرياكتنت. فبيقول لي لو سمحت جاوب لي السؤال اللي هو فيل التيبل يعني. فبيقول لي والله الافكت على الريت بتاع الفورورد رياكشن، انا بس عايز ازود هنا نقطه، وهزود كمان الافكت على الريت للباكورد رياكشن. وبعدين يبقى انا كده عندي 3 تيبل جنب، يبقى واحده للفورورد وواحده للباكورد وواحده للايكوليبريم. طيب انا دلوقتي لما اجي اقول الافكت على الريت، هل انا ليه علاقه بشيفتنج او كده؟ لا، الشيفتنج والكلام ده كده خاص بالايكوليبريم بس. يبقى انا الريت بيأثر عليه الحاجات اللي الدكتور شريف قالها عادي خالص، اللي هي الكونسنتريشن والتمبريتشر والبريشر وهكذا اند سو اون، اللي انا لما بزود الحاجات دي بتزود لي الريت اوف رياكشن. فبالتالي انا هنا لو زودت عملت انكريزنج للبريشر، لو عملت انكريز للبريشر يبقى ده هيزود الريت اوف فورورد وكذلك اوف باكورد، هيزود الاثنين. طيب decreasing التمبريتشر ده هيقلل الريت، فهيقلل الريت بتاع الفورورد وكذلك بتاع الباكورد. طيب adding a catalyst هي بينكريز ريت سواء للفورورد او كذلك للباكورد. الاختلاف كله هيبقى في الايكوليبريم بقى. يبقى انا شغلي كله في الايكوليبريم، فمش عايزين نتلخبط في النقطه دي. لما يقول لي افكت على الريت حاجه، ولما يقول لي افكت على الايكوليبريم حاجه. وما يلخبطنيش لما يقول لي ريت اوف فورورد او يقول لي ريت اوف باكورد، الاثنين واحد، ما تختلفش معايا في حاجه. طيب فلما نيجي بقى نتكلم على الافكت على الايكوليبريم، هو بيتكلم هنا على اليلد ده. يعني ايه اللي يحصل لليلد ده؟ هيزيد ولا هيقل ولا مفيش تشينج ليه او كده؟ طيب هو اول حاجه بيقول لي انا لو زودت البريشر ايه اللي هيحصل؟ قلنا البريشر بيعتمد على النمبر اوف مول، فبالتالي لازم احسب النمبر اوف مول بتاعت مين؟ البرودكت الرياكتنت، وكذلك احسب النمبر اوف مول بتاعت الرياكتنت. فالنمبر اوف مول بتاعت الرياكتنت بتاعتي 3 مولز، 1 مول و2 مول، يبقى انا التوتال بتاعي كده 3 مولز. اما هنا 1 مول. يبقى كده انا لو عملت انكريز للبريشر ايه اللي هيحصل؟ هشفت للناحيه اللي عندها ليس بريشر، يبقى هشفت ناحيه السي اتش 3 او اتش. فبالتالي الايفكت بتاع الايكوليبريم على اليلد ده لما ازود البريشر اللي هو هيزود لي السي اتش 3 او اتش. طيب لو انا عملت ديكريزنج للتمبريتشر، هو قال لي ان الرياكشن بتاعك ده كان اندوثيرميك، كان الرياكشن بتاعك اندوثيرميك، يعني انا الهيت بتاعتي كانت هنا في الرياكتنت. وبالتالي انا لو قللت التمبريتشر ايه اللي هيحصل؟ هروح الناحيه اللي فيها الهيت، يبقى بالتالي ايه اللي هيحصل؟ هيقلل اليلد بتاع سي اتش 3 سي او اتش، يبقى ده هيحصل له decreasement هنا. طيب انا لو عملت adding للكاتاليست، adding الكاتاليست does not affect الايكوليبريم، يبقى no change. ليه؟ لان adding a catalyst increase the rate of forward reaction increase the backward reaction at the same rate. يعني بيخليهم هما الاثنين بيزودهم ولكن بيبقوا في نفس ايه؟ ما بيزودش حاجه عن حاجه، بيخليهم هما الاثنين بيزودهم بنفس القوه. هل حد عنده مشكله يا شباب في السؤال ده؟ ماشي. ناخد اكزامبل برضه على الاوكسايد عشان دكتور شريف قالها فايه.
خلي ده معاهم اخر سؤال، ده بتاع
خلاص تمام.
الاوكسايدز. اوكي.
تمام. فناخد اكزامبل على الاوكسايد. دكتور شريف قال ببساطه خالص ان انا عندي الاوكسايد اربع انواع، يا اما يكونوا ميتاليك اوكسايد يا اما يكونوا نون ميتاليك اوكسايد. طيب قلنا بس الاكسبشن لاي ميتاليك بيبقى بيزك، قلنا بس اكسبشن هم حاجتين، الالومنيوم اوكسايد والزنك اوكسايد. فبالتالي دول اللي بيبقوا حاجه اسمها امفوتريك. طيب هنا الومنيوم اوكسايد يبقى ده امفوتريك، اما ده كالسيوم اوكسايد بيز ميتال اوكسايد يبقى ده بيزك. طيب كربون دايوكسيد يبقى ده نون ميتال اوكسايد يبقى ده اسيدك. بعد كده كربون مونوكسيد، فالمونوكسيد من ضمن الحاجات النيوترال. طيب مغنيسيوم اوكسايد ده ميتال اوكسايد يبقى ده بيزك. سلفر دايوكسيد فده نون ميتال اوكسايد يبقى ده نيوترال، يبقى ده قصدي اسيدك. وبالتالي لازم ابقى فاهم الاربع انواع برضو، يعني ايه بيزك، ويعني ايه اسيدك، ويعني ايه نيوترال، ويعني ايه امفوتيريك. قلنا بيزك يعني بيرياكت with الاسيد، والاسيد يعني بيرياكت with البيزك. نيوترال يعني does not react with either acid or base. اما الامفوتيريك لا، هو بيرياكت with both acid and base. فبالتالي مين هنا اللي يقدر يرياكت with الاسيد لكن ما يقدرش يرياكت مع البيز؟ فده طبعا هنا بيتكلم عن البيزك. فانا قايل لكم فوق من البيزك، فنختار من دول للبيزك. طب مين اللي يرياكت مع البيز لكن ما يعملش مع الاسيد؟ يبقى هو الاسيدك، اختار من فوق الاسيدك. طيب مين هنا اللي بيرياكت with both اوف زم؟ يبقى بختار الامفوتريك اللي عندي من هنا. طب مين كانوت رياكت وذ لا اسيد ولا البيز؟ يبقى ده النيوترال عندي، اختار برضو من فوق النيوترال بتاعي.